Now, students, we move with the new topic. The new topic we can have the apparent weight in a lift. So now we start with the new topic, apparent weight in a lift. So give the heading, apparent weight in a lift. Now, before starting this topic, apparent weight in a lift, what do you mean by an apparent weight? We have true weight, that is the actual weight. True weight means that is the actual weight. And apparent weight means observable weight. Observable, what we observe, that is apparent. And what is actual, that is real. Try to understand. Apparent weight means it is the observable weight. What we observe, that is the observable weight. But the true weight is the actual weight. I can give you here the example before going to the actual topic. So before that, like you just consider a weighing machine. You could just consider a weighing machine. एक weighing machine हम consider करेंगे बेटे. उस weighing machine पर just you stand. उसके ऊपर आप ठहर जाइए. Just stand on that weighing machine. Then it will show your weight. Suppose the weight you are measuring, your weight is measuring around 50 kg. 50 units I will take. 50 units. Now, if the weight is 50 units, now you take the same weighing machine and you go inside a lift. Lift में जाइए आप and just close the door of the lift and just stand on the again weighing machine. You will observe your weight as 50 units only, no change, because the lift is at rest. Just you have closed the door, right? Now what you do, just go, you are now, just imagine you are at the ground level. Now you are moving up with an acceleration, up with some acceleration to the 4th floor or the 5th floor. Now when the lift started moving, no student, जब ये lift जब ऊपर start हो गई, जब move होना, तो what happens, you know, if you look at the weighing machine, it is not going to show you the 50 units. Now it is not going to show you the 50 units. Then what it is going to show? It is going to show more than 50 units. More than 50 units. Why? Because the lift is accelerated upwards. तो बेटा यहाँ पे आपको ये देखना जरूरी है कि भाई हाउ द लिफ्ट इज मूविंग. द लिफ्ट इज मूविंग अपवर्ड विथ सम एक्सेलरेशन. सो देयरफॉर व्हाट हैपेंस, you know, the weight, apparent weight, I can say what is the apparent weight. The apparent weight, it is now, it is not exactly 50, it will be more than 50, it may be 52, it may be 55, it may be 56, depending on the value of acceleration, depending on the value of acceleration with which it is moving upwards. I hope it is clear what I mean to say. Now, are you just becoming a fat person once you enter the lift? No, your mass is remaining the same. Mass is not to mass anything. Does it anything happening to the mass? No. Your mass is remaining constant. You yourself will be the same. But what is happening to the weight? Weight is increased. That is, observable weight is increased. Your actual weight is not increasing there. You are not becoming a fat person. So on the lift, if inside the lift on the weighing machine, if you observe the lift is moving upward, your weight will be more than 50. Now, once you have reached your 4th floor, you will have observed that your weight is 55 unit. Now, just go to the again ground floor from the same lift. Now, once the lift is moving down, you know, it started moving down with an acceleration A. So under this situation, what you are going to observe is the weight, that is apparent weight, what is observable weight, what you are observing, it is not 50. It is not 55. It is less than 50 now. कितना होगा बेटा ये? How much it will be? It will be less than 50. It may be 48, it may be 49, it may be like you are 45, depending on the acceleration of the lift. So have you become slim once the lift is going down? No, you are the same. But what is happening? The weight is changing here. The apparent weight is changing because of the acceleration of the lift, which is moving downward. That is the topic what we are going to study under the heading apparent weight in a lift. I hope you have understood the topic what we have discussed. So let us go for the first situation or the first case. The first one, lift moving upwards with acceleration A. Lift moving upward with some acceleration A. So this is the topic, the first one what we are discussing. So what happens, just to say, suppose this is the block whose weight we are calculating, or a person whose weight we are calculating. Now, suppose the lift is moving upward, but where its weight acts, actual weight, always actual weight will be towards the center, towards the ground, that is mg. Now the normal reaction will be upward, normal reaction will be upward, and the lift is moving with some acceleration a. So under this situation, if you see the Newton's second law, F net is equals to ma, that is F is equal to ma. Under this situation, F net is equals to ma. What we are observing, see, we are observing that the lift is moving upward, the weight is acting down, and normal reaction is acting upward. And this normal reaction only indicates the apparent weight. The normal reaction indicates the apparent weight. How much is the apparent weight? Apparent weight means कितना weight बढ़ गया है बेटा. ऐसा नहीं है कि भाई आप मोटे हो गए वहां पे. Just apparent. हम जो observe कर रहे हैं, that is the apparent weight. ठीक है? Now, this is more. Try to understand. I'm writing the equation. F is equals to ma. This is the second Newton's second law. F is equals to ma. So here the net force, if I write, this is moving upward, so N is more. This is N is more, mg is less. So therefore, what I do, N minus mg, because F net we are calculating. This is upwards and this is downwards. So therefore, N minus mg. When the lift is going down, no, so mg will be more. That is mg minus n we have to consider. But here the how the lift is moving, that is very important. The lift is moving upward, so therefore n is more, mg is less. So therefore n minus mg is equal to ma. Now n is equals to what we can say, students, here m, if I take this that side, this is mg plus ma. I'm taking this minus that side. So from this I can write n is equals to m into g plus a. That is what I can say, this is the apparent weight. Normal reaction gives you the apparent weight, m into g plus a. I hope it is clear. So here you can clearly see that the apparent weight is equals to mg plus ma, or here also you can see the normal reaction, that itself indicates the apparent weight. It is true weight, actual weight, plus the force ma. So what do you say, the weight increases or decreases? So it is something mg plus ma. So apparent weight in this situation increases. It is something like plus. Plus means बढ़ता है बेटा value. Value increases. So under this situation, what I have to say here is the apparent weight, that is mg plus ma, is greater than the true weight, that is mg. So at last what I write here, apparent weight is greater than the true weight. Apparent weight is greater than the true weight. Now let us go for the second situation, that is when the lift is moving down with acceleration a. So here it is moving down, the lift is moving down. Now once again we are seeing the situation, that is the lift is moving down with acceleration a. The second situation under apparent weight in a lift, the lift is moving, but how it is moving? It is moving down with some acceleration a. Let us go for the diagram. Suppose this is the floor of the lift on which a block is there. Its weight mg, normal reaction upward, and the lift is moving down with an acceleration a. How to move, how will the approach for this, the same approach for this what we have seen, अभी हम जो देख चुके हैं, whatever the approach we have gone, the same with same approach we have to move, that is F net is equals to ma. What is F net here? It cannot be n minus mg because the lift is moving down, so therefore mg minus n you have to consider. So therefore this is what mg minus n is equals to ma. Mg minus n is equals to ma. So what is this n? What is this n? If I take this n here, so n is equals to mg minus ma. See, students, I'm taking n this side, ma this side. So mg minus ma I'm taking. So this is n is equals to m into g minus a. Now you can see clearly that this is the apparent weight. Apparent weight is equals to m into g minus a. That is also given by the normal reaction. This is just the simplification what I have done here. But apparent weight is given by the normal reaction. Okay. So this is mg minus ma. So weight may say something is subtracted. So what do you say? The apparent weight is more or less? It is less. That's why I said you, when the lift is moving downward, if you take your weight, it will be less than the true weight. It cannot be 50, the example what I have given. So it will be less than 50. The reason here is mg minus ma. Minus means subtraction हो रहा है. That is why we are getting. So यहाँ पे हम लिखेंगे students, apparent weight is less than the true weight. What is the true weight, students? Mg. Mg is the true weight. So in this, mg से subtract किया गया है. Therefore, apparent weight is less than the true weight. I hope you have understood the concept. Please copy it. Now, students, let us move to the next case for apparent weight in a lift. The next case is case 3. And this case 3, what it says, when the lift moves upward, when the lift moves upward or downward with uniform velocity. When the lift is moving upward or when the lift is moving downward with uniform velocity. Uniform velocity. What do you mean by velocity is uniform? Velocity is uniform means acceleration is zero. Acceleration कब zero होता बेटा? You know already कि भाई velocity whenever it is constant, the body is moving with the constant velocity or the uniform velocity, its acceleration is zero. So therefore, what I do, you know, here acceleration I take it as zero. So the formula for the apparent weight when it is moving upward, m into g plus a, and apparent weight when it is moving upward. So what is the value for acceleration? Acceleration is 0, m into g plus 0, that gives you mg. That is equal to mg. This is 0. So that means here apparent weight is mg and true weight is also mg. So therefore here I will write here apparent weight will be equal to the true weight. Now let us see when the lift is moving down with some acceleration, with some uniform velocity, that is acceleration. Again, it is 0, uniform velocity. So therefore, what I do here, the apparent weight is equal to m into g minus a, that is m into g. What is acceleration when the lift is moving with uniform velocity? So therefore, it is 0. Minus 0, that is equals to mg. So here we can say that this is your apparent weight. So under this situation also, apparent weight is equals to the true weight. ये दोनों बराबर है बेटा. So whether the lift is moving upward or downward with uniform velocity, with the same velocity, then we say the apparent weight will be equal to the true weight. That means when you are measuring your weight inside the lift, which is moving upward or downward with uniform velocity, what we have assumed the actual weight is as 50. So therefore here also it will be 50 only. So no change at all. So this is the condition what we have. Next, let us go for the last final condition when the lift is at rest. When the lift is at rest. So under this situation, is at rest means acceleration again in this situation, the lift is at rest. No change in velocity. So therefore, no change in velocity means acceleration is 0. So under this situation also, what we can do, the apparent weight is equals to mg only, because acceleration is 0, and under this equation that is equals to the true weight. The apparent weight and true weight under this situation is also the same. So when the apparent weight of a person in a lift is equal to the true weight, so here three conditions may arise. The lift may move upward with acceleration. The lift moves upward with acceleration is equals to 0. When the lift moves downward with acceleration is equals to 0. And when the lift is at rest, that means again the acceleration is 0. In all the three conditions, we are getting apparent weight is equals to true weight. I hope you have understood the concept of apparent weight in a lift. Okay, now students, we move to the problems on apparent weight in a lift. So the first problem what we are going to discuss on the concept of apparent weight in a lift is, you can see on the board, this is the question. A man weighs 80 kg, means mass of the person is 80 kg. He stands on a weighing machine in a lift which is moving upwards with an uniform acceleration of 5 meter per square second. What would the reading on the scale? That means he is asking us to calculate what is the apparent weight. So here, see, I'm solving the question. How to solve? I'm solving this question. The next question you have to solve. Okay, see, mass is equals to 80 kg. And the lift is moving upwards with an acceleration, and that acceleration is how much? It is 5 meter per square second. What would be the reading of the scale? Reading of the scale means we need to calculate the apparent weight. Apparent weight we have to calculate. So the lift is moving upwards, so the apparent weight is equals to how much? It will be mg, m into g plus a, right? I'll write in that form only what we have studied, m into g plus a. So m is 80, g is 10. As per the question, I'm taking g, I'm taking it as 10. So plus a, it is 5. So 80 into 15. So 80 into 15. So this is what 800 into this, like we are getting 1200, right? 1200 Newton. Now for this question, what I say, the question asked is, no doubt the lift is moving upward, or it may move down also. But the question asked is the mass to be measured as. When the lift moves upward, or it is moving downward with some acceleration, its weight changes. That is what I say, that is the apparent weight changes. When it is moving upward, apparent weight increases. When it is moving downward, apparent weight decreases. But I have never said anything about the mass, that mass is going to increase or mass is going to decrease. The mass of the person or the mass of the body always remains constant. It is not going to vary. So therefore, the answer for this question is m only. M. So whether the lift is moving upward, whether the lift is moving downward, whether the lift is at rest, always the mass of the person or the mass of the object in the lift remains constant. Answer here, it is m.